Hey everybody. The purpose of this video is we're gonna code using Google's Antigravity and have it write the program, do the testing, and facilitate our coding exercises and make our lives a little bit easier. There are some prerequisites for this video. uh, a bit of developer background, right? Understanding of JSON, understanding of Python, some understanding of RESTful API calls, UVI corn, things of that nature. So if you're an existing Python developer, developing RESTful APIs, you can use this video to make yourself a 10x developer or even better, a 100x developer using Google Antigravity, right? How can we make those software agents work for us is what we're going to see in this video. So with that said, without further ado, let's jump right into it. So a few things to deploy first, right? In our Mac, the first thing that we want to do is have uh, a Python package manager installed. I do not like uh, Xcode and all the bulky stuff there, right? So the first thing I generally do is use Astral's UV, and that's what we're gonna do. Well, actually, yeah, probably before that, let's just download Anti-Gravity and have it installed on our system. So Anti-Gravity has four components to it. There's the anti-gravity backend, for the lack of a better term. There's the CLI, there's the IDE, and the SDK. In this video, we will focus on the anti-gravity 2.0, the platform, and the anti-gravity IDE, which is based on Visual Studio. So those are the two things that we will download. As you can see, since I'm working on a Apple Silicon, I went ahead and downloaded the binaries for both Anti-Gravity IDE and IDE 2.0, and you can see them downloaded here. So let's go ahead and install Anti-Gravity first. It's as simple as, dragging and dropping it into the applications folder, which is what we just did. Then moving on to Anti-Gravity IDE. Once again, it is as simple as dragging and dropping Anti-Gravity to the applications folder, which is what we did, and you can see it installing. It's about 700 meg fully exploded. Takes a few seconds. And there we go. So next is the UV package manager for Python that I was talking about. So let's go ahead. It's developed by Astral. So you go to docs.astral.sh and the installation instructions are right there. So the installation instructions can be copied and run on your terminal. And I'll give all this command in comments in a Git gist or something like that. So it's easy for you to follow along if you want to follow along. So there we go. We took the installation instructions, deployed it. Since it is installed, we're gonna add it to our path. Since we're using ZSH, we chose the former one. And to confirm, we run UV version, and there it is. So then we actually have to install Python, right? So UV is just the package manager. So the Python has to be installed, which is what we're gonna do. The command is relatively simple. UV Python install 3.12, which is a relatively compatible version. And that's what we are doing here. And you can ignore the X developer X code because we don't need that. So CPython 3.12 is installed, and we're pretty much ready to rock and roll at this point in time. So we will launch the Antigravity IDE so we can interact with that. Yep, the warning, ignore it. Ta-da! So the first thing we need is to continue with Google, that Google account. So we need to authenticate with your account. Choose the personal account if you have a personal account. Type in your password. Two-factor authentication if you have set it up. Done. Yes, the browser authenticated, and you can see the authentication is success. Continue. I like the dark theme, so I choose dark theme. And I'm gonna generally leave everything to defaults here. The one thing that I will do is in the extensions, I will choose the languages that I normally develop in. Key bindings, if you're a Unix or a Linux user and comfortable with Vim, you can set it up. Normally, I do Python, Go, and Ruby. Don't do a lot of C, C++, or even C sharp these days. So I don't need it, so I unselected it. Everything else, leave it to defaults. If you are developing in C, C++, or C hash, please feel free to leave them there. Here, if you're doing Android development or Firebase development as an example, or Flutter and Dart, please do select it. Otherwise, you can leave it to defaults. And you can always add it later on if you want to. You have to agree to the terms, so we agree to the terms. And there it is. It's installing the extensions, might take just a minute. It's done. So on the far right hand side, you can see the anti-gravity prompt window. This is what is going to be our interface where we can give the instructions to the agent, and the agent will do the actual work for us. So what are we going to do? One of the first things or the first task that we want to do is ask it to code for us. And what shall it code? So one of the first services that I normally try to do is have it develop like a RESTful service. As an example, um, writing a microservice to determine if a given number is prime or not, right? It's relatively simple, straightforward. You know the inputs, you know the outputs, right? You can give that service a number, whether it is 5, 7, 123, whatever, and the service will return to you whether the given number is a prime number or not. So we're gonna ask the agent to write the business logic, write the microservice, do the actual testing, show us the results, and put it all in a working folder. That's what we're about to do. And there it is. So all we're saying is using the base directory of user Shiva projects prime service as the base directory, create a FASTapi app that checks if the given number is prime or not, save it in app.py, then spin up your local server, to test using a terminal tool, and then hit it with curl to verify that it actually works, and save the results to test underscore results.txt file, just as if you would normally do it, right? If you are a developer, these are some of the normal steps that you would go through to write the service, test it locally, and all that good stuff. This time we're not going to do anything. We've given the prompt, we've asked the agent to do the work for us, and it is going into action there. And you can see, right? Generally, you could bypass all these permissions that is asking, but I want to see what it is doing. So I like to kind of keep an eye on what it is doing. So there it is. It's saying, hey, I need to write to this particular path, which is okay, because that's what we wanted to do. So you can say yes, and you can also choose always allow, but I tend not to do that just to keep an eye on things, right? You never know when the agent is going to go rogue. So now that we have granted the permissions, it has written the app because it's a relatively simple app. So it has written the app.py. Now it will move on to doing the actual testing. And you can see actually it's installing all the dependencies, right? Bib, show, FASTAPI, UVI, corn, etc. Xcode is not there. So it knows, right? It's like, hey, I'm going to look for Python, which it did. It found the Python and then all the dependencies. It's a regular developer workflow, right? Since this is a new Mac, I didn't install anything at all. It's going through the motions of deploying all the dependencies, and it will find actually, yeah, you did find it did find UV, and then it's like, oh, okay, maybe I should have written a better prompt to say that UV was available. I did not, but see how smart it was, right? It actually found that I have UV installed, and then it went through the motions of okay, using UV to set up a virtual environment for Python, and then deploying the dependencies inside that um, to uh, to match my environment. It is amazing what these agents can do. Okay, now that it's done all that, it wants to run the test, so it's like, yeah, go for it. And then it's run the test, and then it's gonna save the results in just a second. Yep, there we go. So it has done some basic testing, and now it wants to write the test results. So, ta-da! Test results are out there. And you can see the results. It tested with number 2 is prime, it is true. Number 4, it's a composite number, so the result is false. 17 is a prime number, so it is true. 1 is not a prime, minus not 7 is not a prime. You can see it. It has done all the testing, right? Both positive numbers and negative numbers. It is amazing how much these agents can do on its own. So you can see that it is, two files changed, it has written all the code, etc. We can now open the Prime Service folder and see what it actually did. So I asked it to put it under Projects Prime Service, and you can see, right, all the files right there. Yep, trust the folder because that is ours. And there is the app.py. There's not much to it, right? The code, I did not write the code at all. The agent did all the code. Antigravity wrote everything here. Basic logic, right? Less than 1, less than 3, not equals to the whole 9 yards. And then there are a couple of paths here, the root path, and then the is prime, checker path, and the results that it returns basically. It, it also found the outer bounds, right? Minus 10 to the power of 12 to 10 to the power of 12 is the actual bounds range. So it has even added that. So if you try to give like a 100-digit number, that's not going to work. See how smart it is, right? And then in the test results, you can see because this is a standard RESTful service, the test results are shown as they are, um, outputs from the service, right? Standard JSON payload, so you can see it. Um, the results are pretty clear. So you want to test it. Did it do it right? Right. So let's go run the Python program on our own. Just see um, how well it did. The standard developer work that you would have done had it not been for the agent, right? So now that we have launched the application, so it's running on port 8000, fine. So let's go to port 8000 and do some testing ourselves. There we go. So there's the welcome message, and it shows you the path is prime slash any number. So we will do that. So 123 is false. Okay. So let's do another number. 1237. That is true, right? And then let's add one more number or one more digit. I mean, clearly that's not a prime number because it ends in an 8 and it's a composite number. So let's add 1 is false. Oh, okay. Add one more one, still false. Add 7, still false. Okay. So add 3 is still false. I'm like, oh, okay. How do I know if this is actually false or not, right? So I'm like, wouldn't it be good if we found out what the composites are or the numbers that wouldn't it be nice if we asked for what the factorials are or not the factorial? Yeah, so let's ask it to refactor it, right? Refactor this program to show the divisors. Oh, that's the word I'm looking for. Wouldn't it be nice if we asked the program to show us the divisors for that composite number so we can be sure that the results that it is giving are actually accurate? So let's ask the program to refactor this to show the divisors if it is not prime, so we get an idea of what the given number is divisible by. And you can see it basically completely refactored the program, and it gave you some manual verifications, right? So for 4, 2 and 4 are factorial, or not factorials, divisors. 2 times 2 is 4 actually, and the number itself 4. So great. So once this sounded like a good plan, we asked it to update the application and retest it. That's what it's doing. There we go. It's fine. It's completed with its changes. And we can go back to the app.py and see what it did. And you can see the business logic did not change a lot. However, it added another function for divisors to find the divisors and save it, and then return it along with the results, right? So that's what it did. Pretty cool, huh? Yeah, the implementation plan was already completed, so we don't need this anymore. We can close that. Now we can go back and rerun the program to see how it actually did. So let's go back to our terminal, relaunch the process, and that last number, right? So we can copy that, and then we can go back to the browser and that URL again, and then is service or is prime, sorry. Yeah, there it is. So this time you can actually see what are all the available divisors for that number. Oh, there's a whole bunch of numbers, including 3 apparently. 341, 123, all those big numbers can divide the big number that we give. That is pretty cool actually. But let's do 16 and see. Oh, there you are. So you see all the divisors, right? 16 can be divided by 2, divided by 4, divided by 8, um, excluding 16 and 1, because if those were the only two numbers, then we will know that's a prime number. But everything in between can also divide 16. That is what makes 16 a composite number. So triple one. Oh, wow. Okay. So 3 and 37. Is it true? Is it accurate? So we can just, do a quick 3 times 37 and see if we come up with 137, right? So we use binary calculator. There it is. I usually like command line tools, so you can automate everything, but you can also use the regular calculator to compute that. So 3 times 37, let's see, is triple one. Yep. So 111 is not prime, and the divisors are displayed right in front of you. Pretty awesome, huh? So now we can also, do the curl to give it different numbers, is prime service slash whatever number that you want to give, triple one. Then, if you want it to be pretty printed, you can also pipe it to jQuery, which pretties the output. Oh yeah, just annoying progress. So just do minus silent or S for silent. And there you go. It's just kind of pleasing to see just your results, right? So the numbers 111 and the divisors are given in your JSON output right there. So any service that you write, if you want to, manipulate your JSON or do some automatic testing, you always want command line to be your primary vehicle. So automation is possible. So learning that curl, learning jQuery, and all those options that go along with it will go a long way into it. All right, now we can stop this program. We can, go to the next task. Okay, what is the next task? And you may have seen, you probably are a technologist and you're following Hacker News, and Hacker News is filled with a lot of posts, right? It's just like Reddit for technology people. Now, the challenge is there are way too many posts in um, Hacker News for one person to be able to read everything, understand it, etc. So, what if we had an agent that can read the news, summarize it, and then give us what the top trending Hacker News are, right? So, you can see here, Hacker News is right here. There's pages and pages and pages of posts, right? Some are good, some are like, not so good, some are like just, venting, so on and so forth, right? How do you know what is worth your time? We don't know, right? Which is where the agent comes into picture. So what we're gonna do is we're gonna ask the agent to read through all the posts, summarize the trending posts, and have it give it to us. And the prompt to do that is, relatively simple, right? So there. So we now use a different folder, right? We can open up a new, back in Antigravity, a new chat window. So this doesn't get disturbed. So we'll launch a new window here. If you create profiles, you can use that. If you do not create profiles, that is also fine. Just a new window is fine. So here we have a clean workspace. And the task here, as we have spoken about, is we're asking the agent to use the home projects Hacker News as the base folder and write a script that scrapes the top 5 trending stories on Hacker News right now. Read them, synthesize a short executive summary of what tech is trending today, and write the summary into a beautifully formatted Markdown file called tech_report.md. Save this in that same folder. So anytime we want to read the digest, we can, go there. So it's like a quick digest of Hacker News if you're interested in that. So there it is. It's basically wanting access to that folder. We give access to the folder. Yep. It's now adding other dependencies, right? URL lib, so you can actually download the Hacker News and read through it, and other Python libraries or prerequisites as it needs to. Don't worry about Xcode. It found Python again. Oh, we could have updated the prompt once more to show that we have had UV. But hey, it'll find it eventually, right? That's the beauty of the agent. It found UV and then it's gonna go ahead and do it. It basically is looking for homebrew because this is a Mac system. I don't have homebrew. I like to keep my Mac very clean. So eventually it will hit upon UV and yeah, it's finally it found Python using UV right there. Ta-da! And then now it's like off to the races. It basically wrote the scrape hackernews.python, and then it's gonna run it. It's gonna scrape the output, summarize it for us, and then write it into the output file that we asked it to write. So there it is. Amazing, isn't it? Watch it do its thing. Yep, it is writing the tech report.md. It has completed it, and then it has given us a really good summary of what the news is. So we can go look at it. We can now open the Hacker News folder and the tech report.md. So it's a markdown file. So let's see if we can make this a little bit pretty using a markdown preview or a markdown reader. You can install an extension if you want. I went with Markdown lint at the very bottom, you can see. Yep, trust publisher and install. We'll go back to the file explorer and we will read the preview. And there it is. So it's given us the executive summary and the trending stories and the scores associated with those dashboards, right? So clearly, it is a very digestible version of Hacker News. If you recall, the number of posts in Hacker News was more than 500 plus or something like that, right? Of which now we're talking about next gen database storage, the shift toward unified transactional analytical processing (LTAP) by decoupling Postgres storage into Parquet on S3. How amazing, right? Back in the day, people used to do analytical processing, OLAP separately, a database for that, and then OLTP, transactional processing separate for that. Your analytical processing typically was called the EDW, which had different stores because usually you would write like nightly batch jobs to do things, and your separate transactional system because it needs real time fast responses and quick responses, right? It looks like now we are getting to a stage where both those storages are being combined, and that's where this LTAP is coming from. A unified transactional analytical processing data store on S3. That seems to be more of an Amazon invented thing to me, but hey, we'll see, right? Then something about cognitive ergonomics, high indoor carbon dioxide levels as hidden silent bottleneck for engineering and strategy sessions. Not so much interested in it. So cosmological frontiers, the James Webb Space Telescope JOST, as they call it, revealing unexplained little red dots and ancient black holes, forcing astrophysicists to revise cosmological models. This is an amazing thing, right? Back in the day, we used to have the Hubble telescope. Now, an upgraded version, the James Webb Space Telescope JOST, came into being, and it is taking pictures of in the space and capturing things at an astronomical resolution, way, way, way better than what Hubble was able to give us. And it is now showing astrophysicists new ways of updating their models, right? Whether it is computing the age of the universe, or whether it is calculating the speed at which the universe is expanding. If you are a physics interested person, I highly recommend checking out JAST, the James Webb Space Telescope, and some of the pictures that NASA has shared with the world. Amazing, unbelievable pictures. All right. In other news, we have some Vespa, born from post-war aviation engineering. The Vespa succeeded by prioritizing lightweight aerodynamics and inclusive. Oh wow, it is the LML Vespa. For those of you from India, you might remember we used to have a version of this called the LML Vespa. So it is an iconic motorcycle, clearly, as you can see. Some of your parents may have had it, right? Such an amazing vehicle that has been in existence for 80 years. I think they're coming out with a new version too. I couldn't remember. And then there's more things about great news. Great news. So this is your morning digest of Hacker News based on everything that has happened, right? Amazing. All right. Moving on to another task. I've been kind of thinking about the task one, right? Okay, we have the Python program written, we are a seasoned developer, we know what's going on, the agent did all the work. What if we were given a junior developer or an intern, and we have to explain to them how this program works, what the setup instructions are, how to get bootstrapped so this program can run in their laptop, etc. This would be really annoying for us if we have to write all the readme.md from scratch, right? Okay, here are your requirements, do this, do that, and so on and so forth. What if we could have a beautifully written readme.md for this program, so that we can give it to the junior developer or the intern to say, okay, here you go, go do this, and then have this run on your laptop, and then come back and talk to me, right? Wouldn't that be really cool? Because documentation is one of those hardest things that we could do as developers, and let the agent do that. So once again, all we're doing is we're just saying to the agent, right? We can go back to the original window or even start a new window. It doesn't matter. So in this case, we'll start a new window, and the instructions that we are giving the agent are, hey, read me the prime service directory, analyze what language they are in, what do they do, write a professional readme.md, complete with setup instructions, prerequisites, and a quick architecture summary breakdown. Save the readme.md in that same prime service directory itself, so that we can pass it along to any noobs, right? So with that said, the prompt is ready. Let's hit it. Ta-da! Once again, it's asking for permissions, yada yada. So we can give it all that. Same, more access to the path. It did its magic, right? And then see, it created that document, and then it wrote the readme.md. So we'll go back to the older project, prime service, and let's look at the readme.md. So once again, we'll do the, oh, I didn't open the folder, so I had to open the folder, that's fine. And then open the preview for readme. Ta-da! Amazing, isn't it? A clean, high-performance HTTP API built with FASTapi to determine if a number is prime and returns factors or divisors if it is a composite number. And that was really how we started this program, right? Hey, we first iteration, we just said, tell me if this is a prime or not. The second iteration, we said, hey, refactor this and show me the actual factors or divisors so we can actually validate it. And if you recall, we did double check at least one prime number 111. I think 3 and 37 were the divisors for that composite number, if you remember. So it's implemented in Python using FastAPI, UVI Corn, and Pydantic, etc. And it uses bash shell script. Prerequisites 3.8 plus, setup and installation. How do you do this? Do the Python, do the virtual environment, pip install. Ooh, it did not show UE here. Maybe, yeah, we should have been explicit in the prompt, but that's okay, right? That's an easy fix. If you want the agent to redo it, you can ask it to redo it. And it also has API documentation that it auto-generated. Oh, we killed the terminal program so we can rerun it. So we can see the actual documentation. So this is your Swagger docs essentially, right? So there's the root, which just gives you, welcome to the service kind of a thing. There's nothing to it. The is prime is the actual service endpoint, and it even allows you to, try it out, right? So here, you can try it out real quick. 3, and you can see 3 is a prime number, and it actually shows you the results. Full Swagger docs, the whole 9 yards. Amazing. So we kill the program, come back and read the documentation. If you want to run the test, you can run it like this as well. And in the architecture, it also tells you, right, the client, whether it is curl or browser, is making the call to the FastAPI endpoint, which then is actually doing the validation using the schema, the prime response. And then if prime, check for primality. If composite, then get the divisors, right? Remember, we want to also know the divisors or factors, and check, and then print the results, and then the algorithm that it used and some examples. Amazing readme.md. This is gonna keep your intern pretty busy for a minute or two there. So this is truly the power of the agents. This is truly the power of Google's anti-gravity and everything else. I hope this video was helpful. Let's catch you in the next. Thank you.